Good afternoon, everyone. On behalf of Team 12, we would like to present to you on our Stage 2 of our Project Agent CFO. For this project, we chose Apple Incorporated listed on Nasdaq under the ticker AAPL. We picked Apple because it's a globally listed company with very consistent structured Securities and Exchange Commission filings. For our dataset, we ingested a broad set of recent filings and reports within the last 2 years, ensuring that the subsequent sections are all grounded in recent quality sources from the company itself.
I'm Christina and I'm going to explain why we needed these improvements. Firstly, vector search alone often miss the right pages when figures only appear in tables. And Apple's reports are usually very keyword driven, so adding BM25 gives a much cleaner signal. Secondly, instead of flattening PDFs, we now keep tables and headings, so the model sees structured context rather than a wall of text. Thirdly, a stronger embedding model lets us embed longer chunks accurately, which is important for multi-line financial tables. Finally, complex financial queries are handled by an agent that plans, retrieves, then answers instead of guessing. Moving on, this slide highlights the impact these improvements have on our system. Firstly, Retrieval. We now combine a BM25 index with a FAISS vector store, so each query uses both keyword and semantic signals. Longer questions also get more context blocks automatically. Secondly, layout-aware extraction plus the new embedding model gives us cleaner, longer chunks that are actually about the query, so hallucinated numbers drop and answers point to the right tables. Finally, the plan then agent ties everything together. It decides when to expand search, send matrix to a calculator, and returns traceable answers, which is essential for CFO-style system.
I'm Jacob and I'm presenting to you on Query 1. For Query 1, the baseline model was fast at around 0.8 seconds, but the answer was unreliable. It tried to guess the NRM trend even though the filings didn't contain any interest, income, or average asset data, leading to obvious hallucinations. The optimized model is slower due to the agentic reasoning, but it behaves correctly. It clearly states that NRM cannot be computed from the context and explains why, so the key difference here is accuracy. The improvement is small because the baseline query was already cheap and simple, while the optimized pipeline adds extra retrieval and reasoning steps. The real gain is behavioral. The baseline confidently filled in missing data, while the optimized model recognizes the limits of the context and stops itself. This is important for financial tasks. It's better for the agent to admit insufficient data than to output a confident but incorrect metric.
Hi, I'm Leon. I'm going to present on Query 2. So the baseline for Query 2 was fast but unreliable. It put irrelevant documents, hallucinated missing years, and also used information outside of the provided context. The optimized model, however, using hybrid FAISS plus BM25 and agentic refinement, consistently retrieved the correct 10K and 10Q sections. Although the latency increased, the answers were fully grounded, used only numbers from the context, and produced clearer tables and MDNA drivers. For Query 2, the improvement is modest because OPEX figures only appear in a few quarterly filings, so even the optimized retriever had limited data to work with. The agentic workflow adds some latency, but it provides better grounding. The key learning points are that iterative document search helps capture sections simple vector search misses, and enforcing use only the numbers in context prevents the model from fabricating missing years. Overall, the method is now reliable for CFO-style OPEX analysis, but further gains will require cleaner financial section chunking.
Hi, I'm Danny and I'll be explaining Query 3. So for Query 3, optimized latency increased from the baseline due to agentic reasoning. It is worth noting that CTI does not apply to a non-bank entity like Apple, so the models have come up with slightly different ways of approximating it. The final response from the optimized pipeline is more accurate. The baseline attempts to respond using figures from mixed periods due to retrieval limitations, which causes the result to be unreliable. The optimized one is able to obtain both relevant figures and calculate correct metrics, but still fails to cover the operating income. So why is the overall improvement small? The accuracy boost was accompanied by a latency increase to over 40 seconds, too slow for conversational use. This is due to agentic reasoning and also the increased context size due to iterative search expansion and markdown token overhead. What are the key learning points? Expanding retrieval scope increases accuracy at cost of latency. We also need to control which documents supply numeric input for calculations. The implication is that production systems should be both optimized for latency and accuracy. Future work may improve reducing context size through context summarization and converting markdown tables to token-efficient formats like JSON or CSV. Final insights from the project is that optimizations in the ingestion and retrieval stages improve the response accuracy by providing more relevant context for the final response. Overall, retrieval precision and latency still needs some improvement. The UX impact of high latency can be mitigated by showing the intermediate reasoning steps to let users know the model is working in the background. Lastly, further improvements mainly involve context fidelity, table retrieval, and domain-specific constraints.